Welcome to Signals and System subject classes. Now we are in the third chapter, that is continuous time Fourier series. So this is the second class, in second video. In previous video, I have given the information about the Fourier series, how to write the Fourier series representation. So the Fourier series and Fourier series quotient, I have given the formula. So once again, I am going to write for the Fourier series representation for any periodic signal. So any periodic signal, it can be written in terms of the complex exponential signals, is it? So the continuous periodic signal x of t equal to sigma Fourier series coefficient ak into e power jk omega naught into t k from minus infinity to plus infinity. So ak equal to Fourier series coefficient ak equal to, so 1 by t integral 0 to t into x of t into e power minus j k omega naught into t into dt. So this omega naught equal to, it is a fundamental frequency of the x of t, that equal to 2 pi by fundamental time period t. So this formula also we can write ak equal to 1 by t integral of minus t by 2. So this is, we are doing the integration. So x of t is a time periodic signal. Then just to do the integration within the one time period, that's enough. So minus t by 2 plus t by 2 plus t by 2. So x of t into e power minus j k omega naught into dt. Is it? We will do the another problem. So this is the one, x of t is a periodic signal. So every time period this rectangular pulse is repeating. So this is so this is the time period. So this is minus t by 2. So plus t by 2. So this is minus t1 and this is plus t1. So this is t and 2t. This is minus t and this is minus 2t. Is it? So every time period, so this is one time period. So in this time period, so minus t by 2 plus t by 2. So this cycle, so from here to here, so minus t by 2 minus t1, there is no signal. T1 to plus t by 2, there is no signal, is it? So this magnitude equal to, I'm taking 1, is it? So this is the one x of t signal. So this is a problem. So in mathematical, we can write, I'm going to write, so x of t, so this is 1 for mod t less than t1, is it? 0 for mod t t1 to t by 2, is it? So why we are taking the mod t for positive and negative, is it? This is mathematical expressions for the, so this mod less than T1 is nothing but minus T1 to T1. This is 1 and T1 to T by 2. So this is mod T. So it is, we can take the for the positive and negative, is it? This is the mathematical expression. Then, so what is the Fourier series coefficient? So what is the Fourier series coefficient for this, is it? So this is the one problem, periodic signal. In this problem, so AK, Fourier series coefficient, AK equal to Fourier series coefficient for the given signal, so general formula, so time period 1 by T integral minus T by 2 plus T by 2 x of T into e power minus jk omega naught into T into dt. Now, in the signal, x of t having the magnitude from the minus t1 to t1 only, is it? So minus t by 2 minus, if you split to this integration, minus t by 2 minus t1, so that is called 0, is it? So for the simplification, so it has the magnitude from minus t1 to the plus t1, is it the x of t equal to 1 into e power minus j k omega naught t into dt, is it? So integration, simple integration of the exponential. We know that integration, so integration e power x dx, so e power ax equal to 1 by a into e power x, is it? This is the integration formula. So from that, so 1 by t, so e power minus jk omega naught into t by minus jk omega naught is a constant, is it? This is a constant. So substitute limits minus t1 to the plus t1, is it? Now 1 by t limits 1 by minus j k omega naught bracket. Now substitute e power minus j k omega naught into t1 minus e power. So substituting minus t1, so it becomes positive, is it? So j k omega naught t1. So I am substituting, so multiplying the minus to this equation. So j k omega naught t, so e power j k omega naught t1 minus e power minus j k omega naught into t1. So this is the formula e power j theta minus e power minus j theta by 2j, is it? For the 2j, it becomes the sine function, is it? Already here we have the j, so I am multiplying and dividing by the 2, is it? By 2. So that equal to, so 2 into e power j theta minus e power minus j theta by 2j, that goes to the sine function. So that equal to sine k omega naught t1 by k omega naught into t. So this is the AK formula. So this is AK. So AK in terms of the k, is it? So omega naught is a fundamental with a constant. So this is T1 is a constant. T1 is nothing but this value, is it? T naught is a fundamental time period, is it? Omega naught fundamental frequency. So ak is a function of the k, is it? It is depending on the sine function. Now, based on the t, I'm going to draw the ak function. So previously we got, so ak equal to, so ak equal to 2 sine k omega naught t1 by k equal to omega naught into t, is it? First, I'm taking the t value, time period equal to, time period t equal to 4t1, is it? In terms of the t1. So then we will draw the ak for this condition. Is it? So in this case one, ak equal to, so 2 sine of k 2 pi by t into t1 by k 2 pi by t into t, is it? So dt gets cancelled, 2 gets cancelled. So that equal to sine of k 2 pi by, so here we will get k pi. So t1 gets can 2 cancel. Then here we will get ak equal to sine of k pi t1 by 2 by k pi. Is it? At k equal 0, now I'm going to find the ak value for the k equal 0, 1, 2, 3, 4. Is it? See, whenever k equal to 2, so sorry, so there is no t1, is it? T1 gets cancelled. Now, so this k equal to 1, so k equal 0, so 0 by 0, L hospital rule. So in L hospital rule, so L hospital rule, we are getting value. So a0 equal to L hospital rule. So 0 by 0, differentiate sine function cos k pi by 2 and pi by 2. Is it? In differentiation, we'll get pi by 2 cos k pi by 2 by pi, is it? So pi gets cancelled, that equal to, we will get the 1 by 2. 1 by 2. Next, a1 equal to, so a1, so sine pi by 2, we have the sine pi by 2, that something value. So it existed, so sine pi by 2, that equal to 1. So 1 by pi, is it? At k equal to 2, so a2 equal to, it goes to 0, is it? So substitute k equal to 2 gets cancelled, sine pi equal to 0, is it? So these are values, is it? So it will have the value at the n for k equal 0 and k equal to 1. At 2 equal to, it goes to 0, is it? That I'm going to draw. So this is ak versus k. k0, it's 0, this value equal to here, in assuming this is the sample, is it? So at 1, the sample equal to, I'm taking, so this is, so this is 1, this is minus 1, is it? So at 2 equal, it 2, it is 0, is it? Again at 3, this value, so it will have the value at 3. So this is 3 value. So this is the first sample. So this is 0. Is it? In case 2, so now in case 2 I'm taking t equal to 8t1. Is it? So here I'm going to write ak directly. So sine of k 2 pi by, so t1 t equal to 8t1 into t1 by k pi. Is it k pi? So t1 gets cancelled. We will get ak equal to sine of k pi by 4 by k pi. Is it? Will have the ak. It will have the magnitude from k equal to 0 to the 3. Is it? At k equal 4, it goes to 0. So for this case, so this is ak versus k. So at k equal 0, so this is 1, 2, 3, and 4. So at k equal 4, that equal 0, is it? -1, -2, -3, -4, is it? So 0, 1, 2, 3, at 4, the magnitude equal 0. -2 and -3 and -4. In case 3, now further it is increased, is it? So that is 16t1. So the ak value equal to sine k pi by, now that is 8. So I have directly written this k pi. So it will have the magnitude from k equal 0 to 7. Equal to 8, it goes to 0, is it? So from this diagram we understood that, see, in the first case, so these are the sample, these are called samples, is it? The sample size, the sample value, it is very, it will have the gap is very high, is it? For example, this is the magnitude called 1 by 2, this magnitude called 1 by 5, is it? So here, so goes on, if the time is increases, the time period is increases, the space between the sample decreases. Space means, so this these are the samples values, is it? So these sample values are going to decrease. So here this gap is high, is it? Again, so this gap is going to decrease, is it? Here this is very less, is it? This gap is very less. So T increases, so T increases, the distance between samples, distance between samples decreases. So this is the concept. It is called actually, this is it is called sync function. We will discuss in the, so this is like this, the sync function. You will get, you draw the, for all k value, you will get sync function, is it? So this is sync function. So this is about Fourier series coefficient calculation. Next class we will discuss Fourier series properties. Is it? Okay, thank you.